Hey guys, we're looking at graphically solving simultaneous equations today. Got a problem solving question. The question says line A is parallel to y minus 3x minus 3 equals 0, and it goes through a point 1 and 9, x value of 1, y value of 9. We've got line B. Line B is perpendicular to 2y minus x plus 6 equals 0, and goes through the point of 2, negative 3. And then it asks us to find the simultaneous solution for lines A plus B graphically. So looking at this question, what should stand out to you and why it would be something like a complex familiar question for us in an exam is because it's got the two skills that we need to display. And the first skill is finding parallel and perpendicular lines, which we remember from our linear equations. And the second part is to graph those simultaneous equations and find the graphical solution. So just stepped out the steps we're going to follow here. Step 1, we're going to find what line A is. Step 2, find what line B is. And then step 3, we're going to graph those lines on a bit of graph paper. And we're going to be able to find that point that intersects. And that will be our solve to our simultaneous solution. Just keeping in mind what I mean by that. I've just done a quick one in Desmos, and if we had two linear lines here, which I've written up, and the equations for those lines is y equals 2x plus 3, which is our red line, and y equals 4x plus 1. And we graph those up, and we can see this point right in the middle, which I'm going to zoom in on, which intersects. And if we look at that, we can see that the x value at that point is 1, and the y value is 5. So our simultaneous solution for these two equations, y equals 2x plus 3 and y equals 4x plus 1, would be x equals 1 and y equals 5, because that's the value of this point where the 2 points intersect. So that's what we're going to try and do here with a slightly more complex problem. So like I said, the first thing we're going to do is find this line. So a good bit of a revision for our linear equations. And I've just written down the key points here. The line is parallel to y minus 3x minus 3 equals 0. I've written that it's parallel to it and goes through a point of x equals 1 and y equals 9. So the first thing we need to do is rearrange this equation. Remember, we want to make y the subject of this. So we're going to plus 3x here, we're going to plus 3 here, and we're going to take those over to the other side. What we do to one side, we must do to the other. So we've got y equals 3x plus 3. So I've just rearranged that. Remember, our line is going to be parallel to this equation here. So when something's parallel, it has the same gradient. So if we keep in mind that our formula for the gradient of a line is y equals mx plus c, you can very clearly see that our gradient in this equation is going to be 3. So our m equals 3. So I can sub that value back in the equation, y equals 3x plus c. And I'm going to sub these points in here as my x and y values. I'll do that over here. So remember that x goes first, y goes second. That's my x value, that's my y value. So my y value will be 9. 9 equals 3 lots of my x value, which is 1 plus c. And so that will be 9 equals 3 plus c. We'll take 3 off both sides. So get rid of this over to that side. So 6 equals c. And so going back to my original equation formula of y equals mx plus c, I now have a c value here, and I have that initial m value here. So I now know that the line parallel to y equals 3x plus 3, which goes through the point 1 and 9, is going to be y equals 3x plus 6. So that's line A. We've found line A. And now we need to find line B. I'll do the same thing. I'll write down the key points. So firstly, 2y minus x plus 6. 2y minus x plus 6 equals 0. And we're looking for a perpendicular line. And the point that it goes through is 2, negative 3. 2, negative 3. Now, same step as before, we rearrange it so y is the subject of my equation. So it's going to be a two-stage approach. We need a plus x here and a minus 6 here to both sides. So that will give us 2y equals x minus 6. And then we want to divide both sides by 2. And that will give us y. 2y divided by 2 just gives us the 1y. Then we'll have x divided by 2. And then we'll have 6 divided by 2, or negative 6 divided by 2, which gives us negative 3. So that's our rearranged version of the equation which our line B is perpendicular to. And then what you should remember from your linear equations is a very specific formula for finding perpendicular lines, and that is that m1 times m2 equals negative 1. If you've forgotten that, go back to your linear equation stuff, review that, remember why. And so what we know here, once again, if we focus on the fact that our formula for a linear equation is y equals mx plus c, we can see that our m1 value equals a half, because x on 2, that's the equivalent of x times a half, so our m is a half. So we sub that into this equation over here. I'll just highlight it for your visual. So we've got a half times m2 equals negative 1. And then we've got m2 equals negative 1 divided by a half. Or if it's easier for you to picture in your head, m2 equals negative 1 divided by 0.5. Because a half is 0.5 in decimal form. And so that means that our m2 value is negative 2. So now that we know that the gradient of our perpendicular line is negative 2, we just need to find c. We can find c by subbing in these values, which I'll do over here. So we're dealing with y equals mx plus c. We found that our mx equals equals 2x. So y equals 2 negative 2x plus c. And then we can sub in these values up here. We sub them in, always remembering x and then y for our values. So our y value of negative 3 equals negative 2 times 2 plus c. So negative 3 equals negative 4 plus c. Plus 4 to both sides. And that will give us 1 equals c. So, once again, we'll rewrite what our equation is in that y equals mx plus c. So that means that the perpendicular line, which goes through the points 2 and 3, that is perpendicular to 2y minus x plus 6, is going to be y equals 2x plus 1. So there are the two equations. We found line B now. So that's line B. And we had line A up here. Line B. Okay. So now we want to graphically, so we're up to step 3, and I'll put a little heading there. So we're up to step 3, which is graph our two lines. And we now know our two lines are line A equals 3x plus 6, y equals, always remember. I'll rewrite that so it's a bit neater so it makes sense. Line A is y equals, I've forgotten, 3x plus 6, and line B is y equals 2x plus 1. So there are two lines. Now, when we set our step 3, all the way up here was graphical lines to find the simultaneous solution. The way that we graph something is we want to find the x-intercept, and we want to find the y-intercept. And we want to do that for both lines, for line A and line B. So to find our x and y intercepts, you should be very familiar with this. When we find our x-intercept, y equals 0, and when we find our x-intercept, y equals 0. Sorry, when we find our x-intercept, y equals 0, and we find our y-intercept, x equals 0. So we can do that right now. So line A intercepts, we let x equals 0. No, let's start with the x-intercept. We'll let y equals 0. So that means we'll sub it into this equation. So our formula is, our equation is y equals 3x plus 6. We're going to let y equal 0, so 0 equals 3x plus 6. Take 6 from both sides. That's going to give us negative 6 equals 3x. And then we'll divide both sides by 3. And that will give us negative 2 equals x. And then we'll find the y-intercept here. So we're going to let x equal 0. And once again, the equation's the same. Y equals 3x plus 6, because that's our line A. And then y equals 3 lots of 0, because x equals 0 plus 6. 3 times 0 is 0, so that means that y equals 6. Alright, and then we're going to find the line B intercepts. And then we are going to, as we did before, split it in half. This side we'll let y equal 0 because we're trying to find the x-intercept. So our equation is y equals 2x plus 1, which we found before. Now we let y equal 0, so 0 equals 2 lots of x plus 1. We'll take 1 from both sides here. That gives us negative 1. equals 2x plus 1. No, I've made a mistake here. Sorry, remember this was y equals negative 2x plus 1, negative 2x plus 1. Sorry if that fooled you. So this is, I'll start this again. So we're still letting y equals 0, but we're letting y equals 0 in the equation y equals negative 2x plus 1. And then 0 equals negative 2x plus 1. We minus 1 from both sides. And that means that negative 1 equals negative 2x. Divide negative 2 from both sides. And that means that negative 1 divided by negative 2 is just positive 0.5 equals x. Negative 2x divided by negative 2 gives us x. And then we're going to let x equal 0. And so y is going to equal negative 2x plus 1. Y equals negative 2 times our x value of 0 plus 1. Negative 2 times 0 is just 0, so y equals 1. So now that I've got all my intercepts, just write down exactly what they are. So when y equals 0, x equals negative 2. So for line A, my x-intercept is negative 2, 0. For line A, my y-intercept, when x equals 0, y equals 6. So I've got a point of 0, 6. And for line B, when y equals 0, x equals 0.5. So 0.50. And when x equals 0 over here, y equals 1 for our y-intercept for line B. Brilliant. So now that we have the 4 intercepts for our equations, it's as simple as drawing them up. I'll just put them down here in this graph that I've already created. We'll just write our data so it's easy for us to remember. So we've got y equals 3x plus 6 is our line A, and our intercepts we found were negative 2, 0 was our x-intercept, and our y-intercept was 0 and 6. And then in green we'll put line B, and that equation was y equals 2x, negative 2x. Determined to lose it, negative 2x plus 1. We found our intercepts were x-intercept 0.50 and a y-intercept of 0 and 1. Okay, now that we've got those down, I can draw this up on my graph here. So negative 2 and 0 is here, and 0 and 6 is here. Oh, no, that's not what I wanted. Got rid of the whole line. Let's draw that back up. There we go. Let's make sure the pen's on, not the eraser. So we've got this point here, got that point there. So I can just draw my line linking these two up. Make sure we go through both intercepts. On slightly off key. Keep that. That's the right equation. It's easier with a ruler apparently. There we go. So that line goes through our intercept here of negative 2 and 0. And it goes through our point here of 0 and 6, our y-intercept and our x-intercept. Okay, now we'll draw the other one. And our first point was 0.50, so it's going to be halfway between the 0 and the 1 down here. And then we have y-intercept of x equals 0 and y equals 1, just there. And like we did last time, we can just draw a nice line through those 2 points. We can already see where our graphical solution for this is going to be. We'll drag that up one more, make that a nice consistent line. There we go. What we can see, well, that was slightly off that green one, sorry, I'll redraw that. Let's make sure I got that on the right point. There we go, that's much better. So if we draw all those two lines, we can see where that intersecting point is. Keeping in mind that we had our 2 points here, so we had 0.5 and 0, and then we had on this point here, we had the y-intercept of 0 and 1, which are x and y intercepts for line B. If I zoom in there, I can see, I can see that I've got a x value of -1 and a y value of 3, and that means that the graphical solution for this problem would be -1 and 3. So a bit of a fiddly question, it's a couple of steps, and remember that half of it did come from linear equations, but remember what we did here, we found line A, which was parallel to y minus 3x minus 3, rearranged that equation, which told us the gradient. We used the gradient to find my equation under the form of y equals mx plus c, subbed in the point that we were given, which was 1 and 9, we were able to find a c value, and that gave us line A, which was parallel to y minus 3x minus 3 equals 0, and ended up being y equals 3x plus 6. And then we had line B, which is perpendicular. Remember that formula, m1 times m2 equals -1. Really important formula to know with linear equations. We used that to find our gradient. We found our c value, and that gave us line B of y equals -2x plus 1. And once we had those lines, we were able to find the x-intercept and find the y-intercepts of line A and line B. That's by subbing the corresponding 0 values. So when looking for the x-intercept, our y value is 0. We're looking for the y-intercept, our x value is 0. Subbed in those values into the equation. They gave us our 2 intercepts for each line, and then we just drew the lines based off their intercepts, and we could find that intersecting point, which we found was at -1 and 3, and so therefore, to get full marks, we say something like, therefore, the simultaneous solution for lines A and B is x equals -1 and y equals 3. That's all there is to it. I hope that made sense. See you on the next video.